Take a look at synthetic division, specifically when we divide by a first degree binomial. Who knows their vocab? What is a first degree binomial?
Something with two terms, with the highest, there's no, the highest exponent as well.
Very good. Perfectly described. That would be a first degree binomial. There are two terms, thus binomial. The highest exponent on x, or the independent variable, is 1. Okay, first degree tells me that it's x to the first power, so I don't even have to put that up there. I know that's there. So if we're dividing by something in this form, okay? So if you're dividing by a quadratic, anything x squared, you're not going to use this. You're going to use long division if you have to. All right, so this is what we're talking about. Simply a way to divide a polynomial by a binomial. The binomial should be in the form x minus c in order for this to work properly. Remember when we had something like x minus h, when we looked at vertex form, and x minus and y minus k? So if I give you a binomial, and I was asking you to divide by x plus 2, how should you write it? Instead of x plus 2, if I want it to be in this form, how should you write it properly?
X minus negative 2.
X minus negative 2. Keep that in the back of your mind. Whenever you see something as positive, think of it as subtracting a negative. Right? We're going to carry that over into the next line. So we're going to divide this polynomial by this binomial. And the first one I'm going to do for you, I'm going to demonstrate the method. And what you can do is you can check with long division to see that you'll get the same answer. Okay, this is just a technique to make things a little bit easier on you. So here's how we're going to do it. We're going to look at our original polynomial. We're going to write it in order. So start by writing the original polynomial in order. What should the order be written as if I'm writing in the correct order from highest to lowest degree?
Negative 2x over 4 plus 3x squared plus 7x.
You okay? Get some water if you're tired. You still like yawned your way through that statement. And you're dividing it by x minus 3, which is in already the correct form. Now, what do you notice about this polynomial? What do you notice about this polynomial?
There's no x cubed.
No x cubed.
There's no c.
And there's no constant term. C. Very good. No, C is perfect. That's good. No constant term there. So if we were to do long division, if we did long division, right, we would go like this. We'd put this on the outside, and for long division, we would do this. That's what long division would look like. And we know that already, right? Synthetic division looks just like long division. You're going to use the same symbol, actually, this division symbol. But here's the difference. You're only going to write down the coefficients. You're kind of dropping every variable here. So here's what synthetic division looks like. You write the coefficients above the line only. See all these coefficients here? Take every coefficient and write it above the line, though, instead of below the line. It really doesn't matter. You could write it below the line. I never thought about that. But you actually know. Write it below the line. You'll see why. Later, we're going to talk about something called a running synthetic division table. Now, on the outside, what you're going to do is this. You're going to take whatever C is, and it's going to go out here. And C comes from the fact that you're dividing some polynomial divided by some binomial x minus c. Remember, this was what we said a moment ago. For synthetic division to work, you're dividing by some quantity x minus c. So what is c in this problem? What is it?
Negative 3.
Negative
No, it's 3.
Why is it 3? But we got to explain why.
Because it's x minus c, so the constant is just the positive number. It's just a number, not the sign.
Yeah, like if you look at this as x minus c, what takes the place of c in the divisor is the number 3. X minus c. X minus 3. C's place has been taken by 3. So you're going to put a 3 outside here. All right? Make sense so far? Is that your lab? Okay, where's your iPad? So, We have the 3 outside. Now, take the first value and bring it down. Okay, so draw yourself a little arrow, only this time. You don't have to do this every time. Bring the first value down. Then, multiply C times whatever is inside. It's similar to long division. It really is. You're multiplying and subtracting in long division. Here, we're multiplying and adding. Multiply these two numbers and add it to whatever's up here. Ready? Some of you are looking. Multiply, add. Write down the number. Go ahead and do it. I know it's 0, so it's not going to help, but just do it. 3 times -2 is -6. -6 plus 0 is -6. So write down -6 then. Then, again, it's distributive, right? This is like distributive. Now distribute the 3 to the next term. Multiply and add. What do you get? What do you get? -15. When you multiply, you get -18, and you add 3, you get -15. Again, Ben, what do you got for the next one? Multiply and add.
You get -38.
Good. And the last one? Mental math. The last one? -114. Multiply and then add 0. So that part at least is easy. -114. Can anybody guess as to what this is going to look like as an answer? Anybody get the idea of where we're going to go with this? Just use perception. You don't know this. I'm just seeing who could perceive. What might I do with all these numbers we got as answers? See all these answers we got? This was our original polynomial, right? This was our divisor, x minus 3. What might these numbers indicate?
Coefficients of the variables
Of the answer, of the quotient. These are the coefficients of the quotient. What's this last number at the end, you think? The remainder. Okay, and we're going to talk about what this means in a minute. So let's jot this down here, please. This becomes negative. The original was x to what power? What did we divide into? X to the 4th. So what is this answer going to be? X to the 3rd. Since we're dividing by something x to the 1st, and the original was x to the 4th, the answer has to be x to the 3rd. That's the polynomial that results, and the -114 is the remainder. So I'm going to write minus 114 over x minus 3. Remember, this is like my mixed number part right here. That's the mixed part of the mixed number, the fractional part. This is like having 3 and a half. The circle is like the half. Now, the method is very similar to long division, but the process you're undergoing just looks different. Okay, but the method is really the same. This is really derived, if you were to derive this formula and where this comes about, it comes about from long division. In long division, you put the answer up top and you multiply and subtract, right? Here we're having the divisor outside, the answer inside, we're multiplying and adding here. Why might we be multiplying and adding? Because we're using x minus c instead of multiplying and subtracting it. Okay, it makes it a lot easier to do this. Now, it's also important because this c value, in a moment I'm going to talk about, has to do with the roots of a polynomial or the zeros of a function. That's where the c value comes into play. Now,
So this only works for binomial,
there is a way to do it with non-binomial divisors, but it's extremely messy and it's not worth it. You're better off using long division. So it's not even worth showing you how to do it, because you wouldn't use it on the test.
so if you have like x squared minus 2, you
Long
just
division.
multiply.
Okay? Now, I'm going to get to the point that I'm getting at in the next example. Go ahead and do this one on your own, please. Try it. You need to use the last one as a model. It might not click what you have to do, so scroll up in your notes and then scroll back down. I'm going to give you about a minute, and then I'm going to write up at least what the beginning should look like. Clearly, your goal right now is to at least fill in this table. Fill in the spots up here Okay, there's 4 spots up there clearly, and fill in this number. That's what I want you to do at least to start, and then go through the rows, or go through the motions. Nick, does Mr. Linus use synthetic line or not?
No.
What does he use for polynomial like zeros? He's trying to find the zeros of the function and they're not integer values.
Not
Yeah.
values?
Like, for example, if the roots are 1/3 and 2/3, right? You can do that using synthetic and irrational root theorem.
I've seen him do that a couple times. He's not really a lot of questions that do
Are they always integer roots? These seem
Yeah,
to be?
probably, yeah.
Okay. And then the calculator ones you use the root finding function on them?
Yeah. He's all about using calculators.
On the half test you can.
Yeah,
Yeah, because half the test you cannot do, right?
exactly.
The half you can, I don't think I ever wrote a thing down. I think I literally used my calculator the entire half the test. On the SAT, I knew math, but I was like a calculator whiz. I did everything with that with the calculator. It doesn't make sense. If you want to conserve time in the SAT, if a problem has like a function, you want to find the roots, grab it, find the x-intercepts. That's your answer. Don't do it by hand. It doesn't make sense. It's quicker on the calculator. Especially like square root equations. We have like the square root of x squared plus 2x equals x plus 5. Graph them in y1 and y2 and find the intersection. What do we have for these numbers? Fill them in for me real quick. The number in front is what? The number in front, the c value? -4. Okay, because clearly this is x minus -4, and whatever this quantity is always goes in the front. Along the top, Ben, what do you got along the top?
2, 9, 1, -12.
Okay. Kelly, step me through. I'm going to bring down the 2 first, then what should I do?
You multiply -4 times 2,
And then,
and you add 9.
what do you get?
1.
Good. Next. Mike?
You multiply -4 by 1.
Good.
We add 1, so we get -3.
Very good. Niall, last one.
You multiply -3 by -4, you get -12, plus you get -24.
Be careful. Try it again.
Oh, right, it's double negative.
So what do you
it's
get?
Positive 12, it's 0.
There it is. Okay. So this is what we're really getting to. This is what the whole crux of this was. Leading up to the idea that what does this mean when the remainder is 0? And we went over this with long division. And we're going to see how synthetic division makes it easy to try things. What did it mean when the remainder was 0?
X plus the divisor is a factor of the dividend.
Exactly right. Very good. The divisor is a factor. So this means the following. We get an answer, yes, is 2x squared plus x minus 3 plus a remainder of 0, so we don't need that. It's like an integer answer with a mixed number only. Well, if that is the answer, if it divided evenly with no remainder, it means that that is a factor. And as Mike just mentioned, the other factor is clearly x plus 4. Now, factor number 1 may also be able to be factored even further. Factor number 1 may be able to be factored even further. And at this point in time, you don't need synthetic. You could just use AC method. Try and factor this with AC method or set up a factoring. Some of you, I think in the past, have used box method to factor here. But I would use AC method to factor this. I don't think it's factorable, else I probably would have written it down. Somebody's more than allowed to check if they want to, but I don't think it's factorable because I do not factor it further. I would have written that down if it were. Okay? So this idea that when the remainder is 0, they are factors, is what this whole chapter is about, kind of. We're going to see in section 8.5 and 8.6 something called the remainder theorem, which is really what we're saying here. The remainder theorem, simply put, has to do with the factors occurring when the remainder is 0. Okay, now there's a lot more to it than just this. For example, if the remainder is a number that's not 0, and there's some sort of a pattern, plus or minus with the signs, it indicates something. It's called Descartes' rule of signs. It has to do with searching for zeros. If the signs alternate or different things, we're going to see we get an upper or lower bound. If this is not 0, but this number is something else, we're going to see what happens. So that's going to lead us into the next section. Okay, so 8.4 is easy because all you do is practicing. We're just going to practice with the next one also. But 8.5, we start to look at the theory behind what this significance is of a synthetic table. Okay, so let's look at the last one here. Ben, you want to read first?
In electrical engineering, Ohm's law is used to relate the resistance, voltage, and current in a circuit. These variables are all functions of time, and Ohm's law says velocity,
Voltage.
equals current times resistance. Find the current circuit if voltage equals 2t to the fourth minus 3t squared plus 4t minus 7, and resistance equals t plus 2.
So we're looking at something where it's a function of time, okay, a function of time. So our goal is to figure out what is the current function in this problem. What is the current function I of t? All right, so I know the law is stated right here. So start by writing this out. How do I get the function I of t by itself? Yeah, divide by r of t. So I of t is v of t over r of t. So it's really this. 2t to the fourth minus 3t squared plus 4t minus 7 over t plus 2. So clearly we have an example where synthetic division is very applicable. We have a polynomial divided by a binomial that is of the first degree. So let's go ahead and figure out what the current function is. We can do this pretty quickly now, and that's what I like to see. So Ryan, give me numbers.
-2 on the left, 2 on the top, -3, 4, and -7.
Why did I leave a space there, Ryan?
The 0.
Good. Don't forget the 0. Okay? Sabine, help me out. Step me through.
You bring down the 2 and multiply -2 by 2 plus 0, which is -4.
Go through the whole one. Go ahead. You can do them all.
Okay, you do -2 times -4, which is 8 plus 3, which is 5. Then -10 plus 4 equals 6. I'm sorry, -6?
Yeah, -10 plus 4. Good.
-2 times -6 is 12 plus -7 is 5.
So what would this current function look like in the end, Nina?
Would equal to 2x to the cubed minus 4x squared plus 5x minus 6 and remainder.
Very good. Okay, very simple. Okay, not a difficult problem, but something like this could look very difficult at first just because it's a word problem. Don't let it psych you out. Okay, any questions on this topic? It's all procedural. Whenever something's procedural, what do you need to do, obviously? What do I always say, guys? To get better at something procedural, what should you do? Practice, okay? Anything that's procedural, just practice a few times. So make sure you get to the homework tonight. Don't put it off till another night. It's all you have to do. Okay, the homework's on the next slide, obviously. So you have 2 review problems I give you. Yeah, 6 problems. Okay, there's no need to do like 30 of these. If you can do these 6 and you can do them right, check the answers for the odd ones in the back. You should be fine with this topic. It's really not a difficult topic, but we're going to expand this topic in the next 3 sections. 8.5, 8.6, and 8.7. So you need to be able to do synthetic division like this. Okay? All right. You should have a good, a few minutes. About 5.